Good afternoon, class. We are looking at chapter 1, review functions and models. Chapter 1, functions and models, covers 4 ways to represent a function, mathematical models, a catalog of essential functions, new functions from old functions, exponential functions, inverse functions, and logs. Four ways to represent a function. We can represent a function verbally by a description in words, numerically by a table of values, visually by a graph, algebraically by an explicit formula, algebraic formula. Input output machine, you put an input, X is the input, the independent variable, f of X or Y is the output, the dependent variable. A pair X comma f of X is created such that, this is read such that X is an element of the D, which stands for the domain. This is read an element of. The vertical line test. A curve in the xy plane is the graph of a function of x if and only if no vertical line intersects the curve more than once. In other words, the x coordinates cannot repeat. A function is called increasing on an interval I if f of x of 1 less than f of x of 2 results in x of 1 being less than x of 2 in that interval, and it's decreasing if f of x of 1 is larger than f of x of 2. That means x of 1 is less than x of 2. In short, increasing means x gets larger, so that's y. Decreasing means x gets larger, y gets smaller. That's all. Horizontal line test. A function is 1-to-1 if and only if no horizontal line intersects the graph more than once. In other words, in this case, not only x can't repeat, because in order to make it function, x can't repeat, the y coordinate can't repeat either. F inverse of f of x equals x for every x is in A, f of f inverse of x equals x for every x is in B. That means f or f inverse or f inverse of f is x when the two functions are inverse functions. So if two functions are inverse functions, their composite function is x. A function is an even function if f of minus x is f of x, and its odd function is if f of minus x is minus f of x. So those are some definitions we should define. Now, we want to find the domain, and it depends on the type of function. As you can see, this is a rational function. In the case of a rational function, the domain is all real numbers except what makes the denominator 0. So you set this equal to 0 and you exclude that. So you could simply write it as x can't be negative 2. So you set this equal to 0, you exclude that, or in an interval notation, you may write minus infinity minus 2 union minus 2 to infinity. Parentheses means open, the endpoints are not included. What about this case? F of x equals 4x cubed minus 5 over x squared plus 3x minus 10. Again, you're dealing with a rational function. We are going to factor the denominator and exclude what makes the denominator 0. X squared plus 3x minus 10. We want two numbers. The product is negative 10. The sum is positive 3, 5, and negative 2. So if you set this one equal to 0, x becomes negative 5. If you set this one equal to 0, x becomes 2. So if we want to go with this method, we would write x can't be negative 5 and x can't be positive 2. However, a proper way of writing it is using interval notation. So you're going to say minus infinity to minus 5, union minus 5 to 2, union 2 to infinity. This is the proper way of writing it. Now, when we go back to this question, is this equal to x minus 2? The reason this question is asked, because we can factor the numerator. Remember, a squared minus b squared equals a minus b times a plus b. So the numerator is x minus 2 times x plus 2. We can get rid of x plus 2. And it becomes x minus 2. However, this is the case everywhere except at this point, at negative 2. So when x is negative 2, that's not the case. So if x is not equal to negative 2, this rational function is identical to this linear function. Okay, so this is a rational function. This is a rational function. And this is a linear function. That's a line. When you draw this line, is it identical to this one? No. You draw this line and it gives you a hole at x equals negative 2. X equals negative 2, you put it here, gives you y equals negative 4. So this line, if you put a hole at negative 2, comma negative 4, then it becomes the given function. So are they identical everywhere except at x equals negative 2? Therefore, no, they are not identical. They are not the same. Determine whether each of the following functions is even, odd, or neither. Reminding everyone, even function means f of minus x is f of x. Odd function is f of minus x is minus f of x. So all you have to do, evaluate f of minus x. This is minus x to the power of 5. This is minus x. As you can see, This is the negation of this statement, and therefore it's minus f of x, which makes it an odd function. This one, g of minus x, 1 minus, replace the x with negative x to an even power is the same. So it's equal to 1 minus x to the power of 4, which is the same as g of x. And therefore g is an even function. What about part C? We plug in minus x in the same manner. And we observe. So what happens? This is minus 2x. This is minus. This remains unchanged as x squared. Is this the same as original function h of x? No. So it's not an even function. Is this the same as the opposite of that? No. It's not an odd function either. Since h of minus x is not equal to h of x and h of minus x is not equal to minus h of x, we conclude that h is neither even nor odd. So pretty straightforward, everybody. Given the graph, where is the function increasing, decreasing, constant? The function is increasing here from -4 to 0. The endpoints, normally we don't write it, okay? We don't normally put it in brackets because could be either or. Where is the function decreasing? Here and here. Over here, from -6 to -4. Over here, from 3 to 6. So union between the two. From -6 to -4, union 3 to 6. Where is the function constant? Right here. From this number to this number. From 0 to 3. Example 4. As dry air moves upward, it expands and cools. If the ground temperature is 20 degrees Celsius and the temperature at a height of 1 kilometer is 10 degrees Celsius, express the temperature T in degrees Celsius as a function of the height h in kilometers. Assuming that a linear model is appropriate, draw a graph of the function. What does the slope represent? So let's write the given. Two pairs are given in the form of h comma t. H comma t. At the ground, height is 0, temperature is 20. At the height of 1 kilometer, 10 degrees. m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Everybody remembers the slope, the equation for the slope. And for here, we're going to put t sub 2 minus t sub 1 over h sub 2 minus h sub 1. I wrote this formula to remind you of the formula we normally use. And I'm writing this formula because we are using different variables. If it helps, let's say this is x, this is y, and then work on it and then put them back. So 10 minus 20 over the numerator, 1 minus 0, the denominator, negative 10 degrees Celsius per kilometer. How do you come up with the units? Units of the numerator, degrees of Celsius, over the units of the denominator, kilometer. So the units work in the same manner. Y equals mx plus b, because we have the y-intercept, we use this one. And instead of y-intercept, we're going to call this one the t-intercept. So instead of y, we are going to say t, mx minus 10h plus 20. Okay. The t-intercept 0, 20, the h-intercept 2, 0. If you set this one equal to 0, h becomes 2. And that's the graph. And the reason this we don't continue, because on this side, we're talking about negative height. The slope, m equals negative 10 degrees centigrade per kilometer. It represents the rate of change of temperature with respect to height. What is the temperature at a height of 2.5 kilometers? In this formula, replace the h with 2.5. Negative 25 plus 20 is negative 5 degrees Celsius. So according to this linear function, at 2.5 kilometers, it should be minus 5 degrees Celsius.
Professor,
Yes.
would it be wrong if we were to plug in the h and t of 1 and 10 to the y equals mx plus b? Or would we still get the same answer?
1 and 10, where is the 1 and 10?
You know how we got 0 and 20
We're
and
talking
1 and
about
10?
here.
Yes. If we were to plug that in for
If
the
you
y
plug
equals
in,
mx,
well,
oh,
y
you know
equals
how,
mx plus b, the reason we use t because of the way they want us to use it, but ultimately this is the same as this one. We are using h instead of x, t instead of y, but if you plug in, this should work. Both pairs should work.
okay.
Otherwise, we've made a mistake. Is that your question?
Yes, that was my question.
Yeah. Okay.
Thank you.
My pleasure. To explain that, I want to make sure everybody understands. After you come up with the equation here,
Mm-hmm.
you can always check with the two pairs. They must work. Otherwise, we have made a mistake somewhere.
Oh, okay. Okay, makes
This
sense.
pair should fit, and so does it. Excellent.
Okay. Thank you.
My pleasure. New functions from old ones, transformation of functions. Just we're going to touch upon that. You should have an idea how to do the translation slash transformation, fairly basic. When the function y equals f of x, if we say plus c, it shifts up by c units. If we say minus c, it goes down by c units. We are assuming c is positive. It makes it easier to understand this. And this shifts along the y-axis. If you have f of x plus c, it shifts to the left by c units, and f of x minus c to the right by c units. And if we happen to have, again, c is larger than 1 because it makes life easier to understand that y equals f of x. If we say y is c times f of x, it gets the y coordinate gets larger by a factor of c. So it gets larger by a factor of c. And if it's 1 over c, it gets shrunk by a factor of c. If you happen to have minus f of x, you flip it over with respect to x. If you say f of minus x, you flip it over with respect to the y-axis. Algebra functions. F plus g of x means f of x plus g of x, f minus g of x, f of x minus g of x, f g of x is f of x times g of x, and f over g is f of x over g of x. This one has always class. Anytime you're dealing with a fraction, denominator can't be 0. Okay, so the assumption is everybody knows, obviously g can't be 0. So that's a given fact. Given that the domain of f is a and domain of g is b, assuming that's the case, the domain for all of this would be their intersection. And of course, the only one you want to be careful, aside from the intersection, you have to get rid of what makes g 0. So if anything makes the denominator 0, you have to exclude it. F of g is f of g of x, g of is g of f of x. That's called a composite function. So just to remind you of those. Now, transformation of functions, absolute value of a function y equals absolute value of f of x. F of x is f of x greater than or equal to 0, and minus f of x if f of x is less than 0. I remind you that absolute value of x by definition is distance from 0. Distance from 0. Therefore, absolute value of x is x if x is greater than or equal to 0, and minus x is if x is less than 0. It's important to understand the concept here. When we say minus x here, we are not referring to a negative value. We are referring to the opposite. What do I mean by that? If somebody says, what is the absolute value of 5, or what is the absolute value of minus 5, everybody knows the answer is 5. This one, you're looking at this part, x, because x is larger than or equal to 0. This one, you're looking at this part. You are saying, because this is negative, the opposite of that number, which makes it this one. So you want to be careful as far as understanding the concept. Okay. And again, I repeat, this doesn't mean negative. It means the opposite of this value in order to make, in other words, x is a positive value itself. Negative x is also a positive value. So with that being, and the same thing happens with the function. So if we are interested in sketching this function, what happens? Let's erase this. First, you drop the absolute value and you graph the function. And everybody should know x, y equals x squared is this. And y equals x squared minus 25 is this one. Again, this is obviously not to scale, but that's the graph. Everybody knows that. So that's the graph. Now, when we want the absolute value of the graph, The portion which is above the x-axis doesn't change. Okay, that remains unchanged. But this portion which is below will flip over with respect to the x-axis. So the part of the graph of f of x that lies above the x-axis remains the same. The part that lies below the x-axis is reflected about the x-axis. So this portion doesn't change, this will flip over. That's how the graph of an absolute value of a function works. By the way, just to remind you, this is the graph of y equals absolute value of x, which is a V shape, okay? This graph. Okay. So that's the graph of absolute value of x squared minus 25. We want to sketch the graph of this function. And to do so, first we want to sketch the graph of square root of x minus 1. So we're going to start with square root of x in fact. So y equals square root of x is one of those essential elementary functions. We should know the graph looks like this. So, for example, this is 1, 1, this is 4, 2, we have 9, 3, and so on. The next one is square root of x minus 1. It's the same graph, but we bring it down by 1 unit. So same graph comes down by 1 unit. So 0, 0, 0, becomes 0 minus 1. So far, so good. What happens with an absolute value is that this portion doesn't change because it's above the x-axis. So this remains unchanged. This one will flip over, go like that. So flip this over. So this part remains the same, okay? This is the part that will flip over. Looking like that, something like that. So that's the final graph.
I'm sorry, Professor, are we always going to flip everything under the x-axis above the x-axis, or does that only apply for when we're, oh, never mind, absolute. I mean, not,
Absolutely. Whenever you have the absolute value of a function, you ignore the absolute value and we graph it. This is what we are doing here. We are ignoring the absolute value when we graph it.
mhm.
Let me erase my. So completely ignore it, graph this one. Then the portion that is below the x-axis, you have to change it. You have to flip it over. And that's by the definition really of absolute value of x or absolute value of f of x.
Got you. Okay, thank you.
My pleasure. Excellent. All right. We are given a function and we are asked to come up with the domain. F of x is square root of x. For even indices, remember, when we don't have an index, the index is 2. Everybody remembers that. That means root 2, right? Square root of x. What's underneath must be positive. So x must be greater than or equal to 0. And we write in this format, x is greater than or equal to 0, or interval format, 0 to infinity. This one, square root of 2 minus x. Again, you're dealing with an index which is even. So 2 minus x must be greater than or equal to 0. And you just can move that here. X is less than or equal to 2. Or from negative infinity to 2. There is a reason that I'm calling it A and B. I'm just using two different interval format. So we have the domain for part A. We have the domain for part B. Again, we should be familiar with the graph. But before we move on to the next part, I want to remind you what happens if, let's say, we had h of x equals cube root of 2 minus x, or for that matter, cube root of x. I hope you remember the graph of cube root of x looks like that, and the domain is all real numbers. When the index, this is the index, when the index is odd, there is no restrictions. Domain is all real numbers. You don't have to do anything. When it's even, then we have a restriction. Now, so that just I want to remind you. We are dealing with an even index. This is, the index is missing because it's the square root, the same thing here. But if, for example, if it's a fourth root, you have to have number 4 here, right? Now, what about what about these two? F plus g of x or f over g of x. The domain is the intersection of the two. For this one, you just find the intersection. For this one, not only you find the intersection, the denominator, namely g, can't be 0. We're going to discuss that. Now, so in both cases, we are looking for, first and foremost, A intersection B, then we make a decision. This is the answer for this one for sure. For part D, we have a little bit more restriction. We're going to discuss it in a moment. But what is the intersection of these two? One goes from 0 to infinity. One goes from negative infinity to 2. If you can see it, more power to you. If you can't, you can always graph it. So for part A, the answer is this, right? All the way go to the right. Whereas for part B, it's from 2 to the left. So I hope you see that the intersection is 0 to 2. Zero is included, yes. 2 is included, yes. This shows that 2 is included, okay, everybody? So that's almost the same for part D, but we want to pay attention to the following, that the denominator can't be 0. As you know, The denominator is 0 at x equals 2. So the answer for this part is the same, except it cannot be 2. Therefore, bracket 0, bracket 2, over here we have bracket 0 comma 2, but parentheses. So this is the change. So x is part of A intersection of B, G can't be 0. So the only difference is this bracket is fine for part C, but it's not fine for part D. So you want to be careful with that. F of x is square root of x minus 3. G of x is x squared. H of x is x cubed plus 6. Find f o g o h. Again, you have all of this available, but in the form of a slide, it makes sense to look at them step by step. Again, you have access to all of this, everybody. It makes more sense to look at them from a slide point of view. There are different ways of approaching it, but ultimately it's by inspection. So we look at FOG, which means f of g of x. FOG means f of g of x. So replace this x with x squared. That's FOG. Now we want to go with FOGOH, which is FOG of H, if you will. So into this, if you replace the X with H, into this goes X cubed plus 6. You're done. This is one way to do that. Or you could do GOH first. It doesn't matter. What is GOH? Take a look at the G. Take a look at the H. GOH, that means into X goes X cubed plus 6. So replace the X with this statement. You get X cubed plus 6 to the power of 2. And now if you go to FOGOH, go to F of X, replace the X with this statement. And I hope you recognize it as what we had here. So it makes no difference. Different ways of approaching them just as good. Exponential functions. Y or f of x is b to the power of x. B must be positive and b can't be 1. It's a continuous function. So y equals b to the power of x. When b is between 0 and 1, we have an exponential decay. When we have b larger than 1, we have an exponential growth. And when we have b equals 1, it is not an exponential function. This is a horizontal line. That's why b cannot be equal to 1. This is not an exponential function. All of them have the same y-intercept, 0, 1. All of them are continuous. All of them have the same y-intercept, no x-intercept. All of them have the same domain, negative to positive infinity. These two that are exponential have the same range, 0 to infinity. And horizontal asymptote, the x-axis or y equal to 0. Vertical asymptote does not exist. So, do you have to memorize that? Absolutely not. But you need to know the graph, and the moment the graph is in your mind, this will give you all of this, I hope. That's why the elementary functions, the essential functions, you should know the graph. It doesn't have to be perfect, doesn't have to be exact. It has to be rough estimate, and the rough estimate of this will give you all of this. So what's the difference? Everything is the same, except this is decreasing, this is increasing. So when b is larger than 1, it's increasing. What does it mean? The limit of f of x as x approaches infinity is infinity. So as x goes to, that is really essentially the end behavior of the function we have studied in algebra. As x goes to infinity, so does y. But as x goes to negative infinity, f of x goes to 0, which is the definition of a horizontal asymptote. On the other hand, for this guy, when b is between 0 and 1, it's a decreasing function. Limit of f of x as x approaches infinity is 0. This is the definition of a horizontal asymptote. But the limit of f of x as x approaches negative infinity blows up to positive infinity. Also, these are exponential rules we have seen. I hope everybody's comfortable with those. We should know them. For example, a to the power of 0 is 1, a to the power of m times a to the power of n is a to the power of m plus n. This is the product rule. A to the power of m over a to the power of n is a to the power of m minus n, the quotient rule. A to the power a over b to the power of n, you individually raise them to the power. Negative exponential rule, flip it over. All these three are negative exponential rules. Take a look. You have a negative exponent, just move it down, bring it up, bring it down, and if it's a over b, flip it over. And this is the power rule. A to the power of m to the power of n is a to the power of m. I'm assuming you know that. So these are important for everybody to know. Sketch the graph of this function. Y equals 1/2 e to the power minus x minus 1, and determine its domain and range. Let's do that. We start with the basic function, essential function, elementary function, y equals e to the power of x, and we should know the graph. It looks like that. Again, it doesn't have to be perfect, but we must know this. The next one is to get this. So we're gonna go from e to the power of x to e to the power minus x. That means reflection about the y-axis. Flip it over with respect to the y-axis, and it looks like that. Then we look at the half, so it's the same thing, but it's been compressed by a factor of 1/2. So for example, 0, 1 is here, 0, 1 is still here, but over here, when we apply the 1/2, so compress the graph vertically by a factor of 2, so y equals 1/2 e to the power minus x, that 0, 1 now goes to 0, 1/2. Let me just write this. 0, 1 becomes 0, 1/2. And finally, minus 1. So shift the graph down by how many units? 1. So when you do that, here's the final graph, and we want to give the information about the final graph. Here's the x-axis, here's the y-axis. Now, remember, going back to this one, or this one, all of them have the same horizontal asymptote, the x-axis or y equal to 0. Because it's been shifted down by this much, y equals -1 is the new horizontal asymptote. Domain hasn't changed, all real numbers, but the range has. the range for all of them was 0 to infinity. For this one, is from -1 to infinity. Want to determine the domain, everybody? G of t is the square root of 10 to the power of t minus 100. Because it's a square root, this expression underneath must be larger than or equal to 0. We move this, becomes 100 on the right, which is 10 squared. So 10 to the power of t greater than or equal to 10 to the power of 2, then t must be greater than or equal to 2 because of the equality. We keep the equality here. As you know, in this case, part B, as you know, sine of theta, the domain is all real numbers. The domain is all real numbers. So e to the power of t has no restrictions as far as the domain is concerned. Neither does e to the power of t minus 1, so the domain remains as r. So sine of an expression e to the power of t minus 1. What we exclude if this expression requires any exclusion. So again, just to make sure we understand. Imagine you have y equals sine of theta. You know the domain is all real numbers. So if this expression, which is called the argument of sine, by the way, the terminology, I hope you remember, it was this theta, or in this case, this is called the argument of sine or cosine, and you name it, has no restrictions. So that's the case. All right. Solve for t, and reminding you of what we just looked at, the exponential functions. So if you follow this one, which is called the product rule, the sum of these two, so e to the power of, the sum of these two is on the left side. And because they both have the same base e, this exponent must be equal to this exponent. This is x squared plus 2x plus 1, and this is t. And you just solve for t. Find the inverse function where f of x is given as 4x minus 1 over 2x plus 3. So how do we find inverse functions? Number one, we change f of x to y because it makes it easier to work with. Again, this is one method. There's a slightly different method also, but this is just as good. So the reason we do that, because it makes it easy to work with. The next one, we interchange x and y. So y becomes x, x becomes y. Interchange x and y. Now, right here, we do have the inverse function. However, we solve for y, okay? So how do we solve for y? Very simple. X over 1, we do the cross product. We multiply these two, we get 2xy plus 3x. We multiply these two, we get 4y minus 1. We are solving for y. We move things around. We can either move 2xy to the right or 4y to the left, makes no difference. We move the -1 to the right. We end up with this. And as you can see on the right side, we can take the y out. We can take 2y out, but I like to just take the y out for minus 2x. If I divide by 4 minus 2x, I have my inverse. So I'm going to change y into f inverse of x. I hope you remember this process. So let's quickly recap to make sure everybody's in good shape. Number one, we change f of x to y to make life easier. Number two, we interchange x and y. So this becomes x, this becomes y, this becomes y. Number three, solve for y. Takes a couple of steps, you solve for y. Number four, change the name y to f inverse. Did we come up with the correct answer? Well, to prove we haven't made a mistake, we either have to show f of f inverse or f inverse or f equals to f. You don't have to show both. I'm going to show one of them, and I highly recommend you do the other one. So for example, if I want to look at f of f inverse, that means I will replace the x here with f inverse. So I want to check to see if I have it right or wrong. F of f inverse means into this function goes f inverse instead of x. This is a complex fraction. The fastest and easiest way to simplify a complex fraction is to multiply by LCD. There is only one fraction at top and one fraction at the bottom. So multiply the top and the bottom by 4 minus 2x. So what happens? When you multiply these two, the denominator cancels out. You get 4 times 3x plus 1. When you multiply these two, minus 1 times 4 minus 2x. When you multiply these two, the denominator goes away. 2 times 3x plus 1 plus 3 times this. So I'm hoping nobody has any problem with complex fractions. This is the fastest way to simplify a complex fraction. Let's distribute. We get 12x plus 4 minus 4 plus 2x. 6x plus 2 plus 12 minus 6x. So the numerator is 14x. The denominator is 14. The answer is x. It's a proof we've come up with the correct answer. A quick recap. How do you find the inverse function? Replace f of x with y to make it easier. Interchange x and y. Solve for y. This is your answer. Change the name to f inverse. That's all there is to it. Check your work, making sure their composite function is x. Logs. Just like exponential functions, b must be positive, b can't be 1. And equivalently, when we say y is log x base b, x equals b to the power of y, which means they have the same base, they have the same exponent. To have a better understanding of this, if we look at this and the arrow, look at the arrow, the movement of the arrow, b to the power of y is x, b to the power of y is x. If we can go from one format to the next, then we have no problem with logs and logarithmic properties. So in the case of a general form where base is any base as long as b is not 1 and it's larger than 0. Here's the properties. Log 1 base b is 0, log b base b is 1, log b to the power of x is x, b to the power of log x b is x, log of x y base b is log x plus log y same base, log of x over y is log x minus log y same base, and log of x to the power of n is n log x same base, namely b. First and foremost, I'm assuming you know all of that, class. If you look at this one, this just follows this arrow. Okay, everybody? This just follows this arrow. Very simple. These two refer to the fact that logarithmic functions and exponential functions are inverse of each other. This is called the product rule. This is called the quotient rule. This is called the power rule. In the case of a common log, the base is a 10. So when we write log x and we don't write the base, we mean the base is 10. And so if y is log x base 10, that means 10 to the power of y is x. So we can rewrite all of those for base 10. So what happens is, don't write the base. Log 1 is 0. Now, look at this number 2. This says if the base and the argument are the same, the answer is 1. When you don't write the base must be 10. That's why it's log 10. And again, numbers 3 and 4 refer to the fact that they are logarithmic functions and exponential functions are inverse functions. Natural log, the base is e. So when we write ln instead of log, when we write ln, we mean log x base. We never write it in this format, as we never write it in this format, okay? We write ln x, which means e to the power of y is x. And this is the general form. This is a specific form. ln1 is 0. If you look at this one again, the base and the argument must be the same because the base is e. The argument must be e. And again, numbers 3 and 4. I hope you can see all of them. Okay, my assumption is we are comfortable. If not, it's coming back to us. Logarithmic properties. Exponential functions, logarithmic functions are inverse functions. Because they are inverse functions, they are symmetric with respect to the line y equals x. Also, we have the change of base formula. Log x with base b is log x over log b. What is the base? Anything you want it to be. You can choose a, some number out of the blue, or you can choose common log base 10, or you can choose e, natural log. The reason we do that, because many calculators can't handle this, so we have to go with the change of base formula. So this page is the synopsis of information about logs. You want to make sure you go back to them to get comfortable. We want to find the inverse function for f of x equals 1 minus e to the power minus x over 1 plus e to the power minus x. And as you recall, the very first step is to change f of x to y because it just makes it easier. The next step is to interchange x and y. So this becomes x, this becomes y, this becomes y. And the next step is to solve for y. To solve for y, we are going to do the cross product. So I'm going to write this one. Let's just move it. Let's just write it as x over 1. And so we have the product of this. So x times 1 plus e to the power minus y equals 1 times 1 minus e to the power minus 1. We are solving for y, do the cross product. So this becomes x, this becomes x e to the power minus y, the right side doesn't change. We don't like e to the power minus y. You have two choices. You can write this as x over e to the power of y, and write this one as 1 over e to the power of y with the negative sign. Or just the way it is, you recognize you can multiply by e to the power of y to get rid of it. So if I multiply both sides by e to the power of y, what happens? This becomes e to the power of yx. This one with e to the power of 1 becomes e to the power of 0 becomes 1. They cancel each other, we get x. This one is e to the power of y. This one becomes minus 1. I hope you recognize the product works out this way. We are solving for y. Anything involving y must come together. Therefore, we move this one, we move this one. They change sign. On the left side, we solve for e to the power of y. That means we factor. Divide by x minus 1. Both sides. And now, one thing I want to make a point of, you can leave it like that. There is nothing wrong with that. However, as you can see, there are too many negative signs. You can say, okay, I'm going to multiply the top by -1 and the bottom by -1. If I multiply the top by -1, becomes positive x positive 1, and the bottom becomes negative x positive 1. So 1 minus x. Again, do you have to make that change? No, but this looks a lot better than this one. Your choice. Right? Everybody remembers this from the previous page? Y equals ln x means e to the power of y is x. That means y is ln of the right side. Or you can even do the following. If I take the natural log of the left side and natural log of the right side, the left side becomes y. However you want to look at that. And you're done. Just call y f inverse of x. Change the y into f inverse. This is a question that you want to pay attention to make sure you're comfortable with that. Logarithmic properties. Write as a single log 1/3 ln of x plus 2 cubed plus 1/2 ln x minus ln of x squared plus 3x plus 2 quantity squared. And these are the properties, the general properties that we have seen. Honestly, this can be done in one shot, but Let's take a couple of steps. First and foremost, look at number 7. We can go from left to right or from right to left. I'm going from right to left. So 1/3 times 3. So 1/3 becomes the exponent. So this to the power of 1/3 becomes x plus 2. This one, let's actually do this. Let's get rid of the bracket, everybody. Half of ln x minus half. So I'm distributing number 1/2, okay? So one more time. So as I mentioned, this one is ln of this to the power of 1/3. So 3 and 1/3 cancel each other. 1/2 times ln x minus 1/2 times ln of x squared plus 3x plus half. Now this 1/2 becomes the exponent. So here's what happens in other words. This now raise it to the power of 1/3 and get rid of that. This raise it to the power of 1/2. This raise it to the power of 1/2 and get rid of that. So you get this one. Can you see this one, everybody? So quickly, let me recap this. You have a 1/3 here with these 3. They cancel each other. They give you 1. You have 1/2 ln x is ln of x to the power of 1/2. You have 1/2 ln of this mess to the power of 2. So you raise this to the power of 1/2, 2 and 1/2, then cancel each other, you get 1. So that's what you have. Now, anything that has a plus sign goes to the top, anything that has a negative sign goes to the bottom. I'm looking at the combination of 5 and 6, everybody. So just for the sake of argument, this 2, you can write ln of x plus 2 times x to the power of 1/2 or square root of x. This piece is the product of x plus 2 and x plus 1. So using the quotient rule, this is the ln of this piece at top, this piece at the bottom. So again, ln of x plus 2 square root of x, this is the numerator, minus ln of x plus 2x plus 1. This piece is at the bottom. And now you have the final answer. Ln of x plus y plus ln of x minus y minus 10 ln z. First and foremost, I'm going to make this z to the power of 10. Then by now you should be able to do this in one shot. Ln of a fraction bar. So you basically write down ln of a fraction bar. What comes at top? The product of this and this one, because we have a plus sign. What goes at the bottom? Because we have a negative sign, z to the power of 10. Ln of x squared, so x plus y times x minus y. Maybe I write it here first. So ln of x squared minus y squared over z to the power of 10. Now we want to go the reverse process. We want to expand it, okay? So either you put them together as a single log or you expand it. In order to expand this, you need to get rid of the square root and write it to the power of 1/2 first. Okay, that's your first step. The next step is to get rid of 1/2, put it in front. So it's 1/2 log of x minus 1 over x plus 1. Now log of x minus 1 over x plus 1, you can use number 6. So 1/2 log of x minus 1 minus log of x plus 1, number 6. So we have covered a lot of properties here, everybody. Okay, you should be comfortable with that. Okay, there's really not much to it, but a little bit of a practice, and it makes it nice and easy. We want to solve equations ln of x squared minus 1 equals 3. E to the third is x squared minus 1, right? By definition. Move this, make it plus 1. And x is plus minus the square root of that. Now, it is important to make sure the argument of log is positive. And the reason both answers work because you're raising them to the power of 2, regardless becomes positive. And then minus 1 takes away 1 and still positive, okay? For example, if you put negative square root of 1 plus e cubed, square root of that in there, gives you 1 plus e cubed minus 1 becomes e cubed, ln of e cubed is 3. You want to solve this, and you have two choices. You can solve it just the way it is, or you can go by substitution by letting this be, for example, y. If you do that, then you're dealing with y squared minus 3y plus 2 equals 0. And that, you know, you want two numbers, the product is 2, the sum is -3, so you have y minus 1, y minus 2 equal to 0. Replace the y with e to the power of x. Or you may recognize it that you don't have to use the substitution. You're comfortable with that just the way it is, e to the power of x minus 1, e to the power of x minus 2. It's your choice. If the substitution helps, by all means. This means e to the power of x is 1. This means e to the power of x must be 2. We are solving for x. This means x is ln of 1, which is 0. This means x is ln of 2.
I know that that would help, so.
ln of ln x equals 1. Remember the arrow. So what's in there equals e to the power of 1. Ln x is e to the power of 1 or e. And now you do it again. X is e to the power of e. E to the power of ax is c e to the power of bx. And we want to solve for x. So the methodology is to divide both sides by e to the power of bx. Now the left side using the quotient rule is e to the power of ax minus bx, or e to the power of a minus b times x, either way. The right side doesn't change. And e to the power of a minus b x equals c. You may recognize the definition, or maybe you don't. If you don't, just take the natural log of both sides. The right side is ln c, the left side, the natural log, and e to the power cancel each other. They give us a minus b times x. And so x is the right side, ln c divided by the parentheses a minus b. That's how you solve. Ln of 2x plus 1 equals 2 minus ln x. Anytime you have logarithmic equations, if they are all logs, just combine each side into a single log. If they are not, bring all the logs together. So this must move to the left. Combine these two into a single log. And now go by the definition. E squared is x times 2x plus 1. This is 2x squared. This is x equals e squared. To solve this, we're going to move the e squared to the left. And now we are going to use the quadratic formula on that because it can't be done by factoring. QF, short for the quadratic formula, ax squared plus bx plus c equals 0. X is minus b plus minus a squared of b squared minus 4ac over 2a. So what is a? 2. What is b? 1. What is c? Negative e squared. Plug it in. All right, plug it in. What do we get? Negative 1, 4, those are easy. This is 1, this is 8 with negative positive 8 e squared. There are two answers. Are they both acceptable? One of them is negative 1 minus square root of 1 plus 8 e squared. One of them is negative 1 plus square root of 1 plus 8e squared. Clearly, minus 1 minus the square root of 1 plus 8e squared over 4, even if you don't know a rough estimate, you do know that it's negative and it's unacceptable. The only acceptable answer is positive. Why is that? Because x can't be negative. It can't even be 0. This one says x must be larger than 0. This one says x must be larger than negative 1/2. Okay, but we go with that one. In any event, it doesn't work. There are two answers. One of them is acceptable. Prove cosine of sine inverse of x is square root of 1 minus x squared. We are dealing with trigonometry, inverse functions. So as we come across them, I give you the synopsis of that as need be. Remember, when we say sine inverse of x is equal to theta, by definition means sine theta equals x. Everybody remembers that, right? So therefore, when we say cosine of sine inverse of x, sine inverse of x represents an arc or an angle, so you're looking for cosine theta. It's important to know this means some sort of an arc or angle. So we are looking for cosine theta. So let's find out what's going on. According to this, sine theta must be x. And everybody knows sine squared plus cosine squared equals what, right? This is one of Pythagorean identities in trigonometry. 1 plus tan squared equals secant squared. 1 plus cotangent squared equals cosecant squared. So those are the other two. All right. So with that being the case, when we know that, that means we know cosine is plus minus square root of 1 minus sine squared theta, square root of that. That means we know sine theta is plus minus square root of 1 minus cosine squared. So those are given. Knowing this, we should know that. So what is sine x? So what is sine squared? X squared. So this can be replaced by x squared. Plus minus, which one? Plus. Why is that? Remember, trigonometric functions do not have an inverse unless we restrict their domain, because there are periodic functions and they repeat. Therefore, none of them has an inverse unless we do the restriction. The restriction done on sine was x is between negative and positive power 2, which puts us in the fourth and the first quadrant. In the fourth and first quadrant, cosine is positive. That's why you choose from plus minus, you choose the positive one only. So you want cosine theta, and cosine theta is plus minus. Which one do we choose? The positive one, and here's the reason. To do this, let me clean up the mess. Sine of 2 arc cosine x. I hope you remember by arc cosine x, it's the same as saying cosine inverse x. And so when we say arc cosine x equals theta, okay, that means we are looking at sine 2 theta. Class, sine of this is 2 theta. That's what we are looking for. And this means cosine theta must be x. And again, you're looking for sine 2 theta, you should know it's 2 sine theta cosine theta. It's one of those identities. Sine of 2 theta is 2 sine theta cosine theta. Cosine squared is cosine squared. Cosine 2 theta is cosine squared minus sine squared. Or 1 minus 2 sine squared, or 2 cosine squared minus 1. And so 2 sine theta cosine theta, and we have cosine theta. So far so good, but we don't have sine theta. And sine theta is plus minus the square root of 1 minus cosine squared theta, square root of that by Pythagorean identity. Which one do we choose for sine, positive or negative? We choose the positive. So 2 sine theta, we choose the positive of this one, 1 minus cosine squared. We replace the cosine with x, and then times cosine theta times x, and we rewrite it in this fashion. Why did we choose the plus sign? Why not the negative sign? Because when y is equal to cosine x, we restrict the domain from 0 to pi in order to make it a 1-to-1 function, so it has an inverse. In the first and second quadrant, sign is positive. I hope they're coming back to us in case we forgot, okay? So everything has a reason. So you can't go from plus minus to plus and say, okay, it just works like that. You have to have a justification. Here's the justification here. Here's the justification here. And other identities that we should know. We want to solve this exponential equations. E to the power of minus x squared is e to the power of x to the second power times 1 over e cubed. All we have to do, combine, use something here, and combine them such that it becomes doable. This is e to the power minus x to minus x squared, and that's something with the base e. The right side, we can do the same thing, and we can set them equal. This one is e to the power of 2x, right? E to the power of 2x times this one, that means e to the power of 2x minus 3. So the left side we don't touch. The right side, first we do the power rule to combine into 2x here, and then we use the quotient rule to say e to the power of 2x minus 3. Because they have the same base, they must have the same exponent. They are identical. Minus x squared equals 2x minus 3. To solve this, we bring everything to the right so we can factor it. If you move this to the right, you get 0 equals x squared plus 2x minus 3. And now you want two numbers. The product is negative 3. The sum is 2. So x plus 3x minus 1. The answer is either negative 3 or 1. Those are the answers. For a case like this, where we have different bases, the question is, can we come up with the same base? We can change this to 3 squared. So this becomes 3 to the power 4x. This becomes 3 cubed, 3 to the power of 3x squared. So now they all have the same base. On the left side, we can combine this and we get 3 to the power of 4x plus 3x squared using the product rule. Both sides have the same base 3. They must have the same exponent. 4x plus 3x squared must be equal to negative 1. We move the negative 1 and we do the factoring. Because 3 is a prime number, it's simple, it's 1 and 3. And of course, this is 1 and 1 only. And so we end up with this. resulting x in x being either -1 or -1/3, and those are the final answer.